That is the beauty of AI, is that it really opens up a whole world of possibilities. And we are going to talk about those possibilities today. And part of that is going on a bit of a treasure hunt, as Rick kind of alluded to here. But to do that, every quest needs some tools, right? So when I was thinking about, putting this show together, I kept running into all these phrases that I want to use, but I worry that not everyone has this shared language, especially if English isn't your first language. Then you have that to contend with on top of it. So we're going to level set with a couple of key terms that we think you should know, not only for this show, but frankly, any kind of interaction you have with AI. The first is going to be neural networks. And this was really like my first game changer into understanding what modern AI looks like. Neural networks are basically the back end of how any type of AI is built, whether it's analytical, predictive, generative, even agentic. They all have some concept of neural networks. And the idea here is if we're replicating human intelligence, i.e., artificial intelligence, then you have to think about things in terms of patterns. When you're first born, you are actually having the biggest explosion of neurons created in your brain. So babies are taking in inputs and they're learning more about, human faces and what expressions are good and what stimuli they need to respond to, like I'm hungry. And as time goes on, they start to build stronger and stronger connections that help them interact with the world. And then at a certain point, around the age of 5, our neural networks start to not grow as much. And in fact, you even start to learn something called pruning, where you're clipping things in order to be able to make connections faster. You don't have to take as many steps. So artificial intelligence, what it's trying to do is replicate that idea of learned experience, creating patterns and connections. So any kind of AI is going to have some sort of input. For generative, it might be written prompt. And then it will go through a sequence of patterns that it has learned using machine learning and then come out with an output. And that output might be right, it might be kind of right, it might be super wrong. And it takes a human today to figure that out, which we'll get to in just a second. Rick, anything you want to add about neural networks? I don't know if we can get better than my existential baby boom, idea here, but.
Well, and I got a quote, and you'll maybe appreciate this. And when we map this type of mindset to AI, we're on a journey, right? This growth and these clipping, the just contraction and verification. And I've heard someone say today's AI is the worst AI you'll ever use. I think you might even say that again later. But no, this is really not something that I personally have really thought about. And, I identify more a couple other of these tiles of how I approach AI, but no, that makes sense. Nothing to add beyond that.
And the tools are going to build with this story because it's got to start big and then kind of work its way downward. So the second keyword that I want everybody to understand is the word context, which most people know the word context. But what we're talking about here is from a technical perspective, what does context mean? Ultimately, context is the way that we are applying artificial intelligence to specific use cases, putting the patterns in context so that it stops just parroting and starts building understanding, right? Sharpening the relevance and the meaning here. So think of something like you type in the word bat. Does that mean baseball bat? Does it mean Batman? Does it mean literally a flying mammal? The context around it can make a really big difference. And that's where the third term comes into play, human in the loop. This is another one of my favorite stories to tell. Back in the day when NASA was executing some of its first key missions, there was the Apollo mission. And there was an engineer named Margaret Hamilton. She was a software engineer, and she was responsible for guidance and control systems. The other engineers and scientists all felt that the Apollo mission was ready to go. They had programmed 10 sets of guidance for this mission. And they felt that no matter what, the context of whatever was happening for the astronauts on board would fall into one of those 10 kind of guidance systems. And Margaret said, no, I don't trust the computers to do that by themselves. I think we need to arm the astronauts with worst case scenario protocols. And they thought she was crazy. But ultimately, they allowed her to print out this massive stack of papers. And there's even a picture online you can see of the stack of papers being almost as tall as she is. And they put it on board of the Apollo. And guess what? They needed to use it. So she coined this term, human in the loop, the idea that we can trust computers all day long, but there needs to be a human in the loop. And especially for anyone who's maybe nervous about artificial intelligence or recognizes that there's a lot of misinformation and hallucinations that happen with the AI outputs, this is where that human in the loop concept comes in handy. And Rick, I know we're going to talk a lot about how actual humans with real butts and seats can use a lot of these AI tools to augment their work. Anything you'd want to add here about human in the loop concepts?
No, I mean, I think this maps really well to my bias to explainability. And I think it's super important because if you think about kind of the makeup of, the corporate world, Generation Z entering the workforce right now is the first kind of AI native generation. And, they don't have like a whole career behind them of whatever they're doing to base it on. So I like to put that human in the loop at that last output, right? And
Yep.
from an explainability standpoint. And I think it's just an additional perspective on it. But no, I think, now and then and later, I think the human in the loop concept, I think it will scale. I don't know if we need to be wheeling around a stack of papers as tall as each person, or how far and maybe less the human in the loop will be, coupled with the innovations we'll see. I think that this is an important concept. I call it explainability, but absolutely then what to do if not. And escape logic, that's another one that you could I love actually playing with the Veeam own AI. Best example I think I did it at Veeam last year, is I asked Veeam Intelligence why green beans don't have as much fiber as regular beans, right? And you would be really surprised it handled it correctly. But then I went to a different AI solution that we were working on at the time, and it actually just broke. Okay, so then you got to think about those types of things. Are we going to have a consistent experience, right? But human in the loop, QA, escape logic, explainability, all of that stuff, highly recommended.
Yeah, I think too, when you compare different models, some of them have looser concepts, and others have tighter concepts. Anthropic, for example, does something called constitutional AI, where it filters the output through their own constitution of ethics prior to it coming out. And, that's something that I've tried to start doing with my own interactions. I'd love to know from you guys in the chat, what is the stupidest, most incorrect answer you've gotten from a GPT tool? The other day, I was trying to get just a quick summary on a book by John Green, who has a brother named Hank Green. And in all candor, I can't remember which one is which most of the time. I know for a fact, though, I typed in the wrong Green name. And I said, book name, wrong Green name, please give me a summary. And the answer back just repeated the wrong name that I said. And I had to go back to Beckett and say, hey, man, you need to call me out when I typed something in wrong. So let us know in the chat what you're getting is some of these really awful responses. There's been some pretty funny hallucinations that I've seen online. Would love to know in the chat what you guys have been seeing.
Oh, well, take my green bean example. That's one on like a text GPT, but I think we all can relate to some of the image generation
Yes.
examples early on. Why did everybody have several extra legs? And why does this, too little, too few fingers and things like that. So we saw a lot of that. We also had, I think still to this day, slightly misrepresented text and things like that, misspellings. And I think there's actually, it's because of some logic of, it's like some copywriting and things like that.
Yep.
So I think we all can relate, especially to some of the imagery.
Oh, gosh, yeah. I tried to have GPT create an image that was supposed to represent like the Force from Star Wars. And I got a
love
lot
that.
of yin and yang symbols, which was weird. Fair enough, but weird.
That
Okay,
language,
cool.
I don't know how to speak that language, and it's different every time I see it. So yeah, I'll
It
go for
is,
that.
right? I get it. Cool. Well, let's talk about stuff that we know when it's not, right? Something that it's not. And that would be entropy analysis. Rick, why don't you tell us a little bit about entropy analysis? Because that was such a core function of one of our past releases of Veeam Data Platform that we really want the community to know about.
These are the simplest way to explain it. Now, this is a little bit of a Veeam lens. Our AI talk so far has been very broad focus, but the way that the implementation that we had as a productized implementation, which, not to shine my own halo, but I think is now going on 2 years in market. That was really around looking at patterns on image-based backups that were consistent from our own learnings of some of these advanced threats. It's the best way to explain it. And the only practical way to do that is on scale with, a AI, and I'm kind of blurring machine learning into this a little bit and some of the different low-level disk patterns that go into stuff like this. But, when you think about some of the threat actors, they have some consistent behaviors across the different actors. And then you build on that. And, in that time, we acquired Coveware and we got some really detailed learnings, which goes into some of the indicators of compromise detection. So when you think about a building block, this entropy analysis, this low-level pattern look, coupled with other kind of more characteristic and wildcard and patterning type of things, coupled with, and you really build on something that's really powerful. You could call it full circle and, a complete approach as well. But this is a very important building block of changes that may not at their face value look like much, but compared to some of the behaviors that we see with some of the threats, it's a match, and it's one of those things that would need immediate attention.
Yeah, it definitely, I think, signals when something is out of place, going back to that pattern recognition concept. And for those who are just joining us, by the way, this is our show talking about AI and specifically how it operates within the context of data resilience. But we're hoping to give you guys some good foundational knowledge that can help you navigate not only how to use AI with Veeam, but AI in the broader context of your work. I'm going to go ahead and skip ahead to one more definition so we can get into some use cases, but I wanted to share a really quick story for anyone who's feeling nervous about this age of AI. You may get called this derogatory term called a Luddite. And everyone who I've said this to has been like, what does that mean? Well, in the 19th century, English textile workers, specifically, I think Luddites were named after someone with the last name Ludd. They were in the textile industry, and they found that automated weaving machines were threatening their ability to maintain employment, i.e., what we're facing right now with the fear of AI automating out our jobs. And they actually staged a revolt where they smashed a bunch of weaving machines in this one textile mill, and it became this example of this anti-industrial revolution movement. But really, what I think that people need to understand about that concept is this was really more about job security than it was about being anti-revolution, anti-industrialization, and in our case, anti-tech. So if anyone ever calls you a Luddite, just know that's a slippery slope. The flip side of that would be boomers, people who really believe that AI is going to boom and change the world and it's going to have all these positive outcomes. It is okay to be skeptical about those outcomes. We've talked a lot today about human loop and defensibility and explainability. We still see a lot of incorrect answers. So it's important that we're all recognizing that slippery slope in between.